Okay, this is a magnetism question. We are asked to calculate the amount of MMF, and that is magneto-motive force, or the source of a magnetic field. Now, here, we'll start this one by calculating the reluctance. And so remember that a magnetic circuit has a source of MMF that will produce a flux field of magnetism in a magnetic circuit, shall we say. Here, we're not really considering a magnetic circuit. What we're considering is that there's an air gap which could, I suppose, occur between the poles of a magnet, or in the construction of a motor, there's an air gap always between the stationary field or stator and the rotating rotor. And so the idea is that how strong of the magnetic field need to be in order to produce a certain flux across that air gap. And so we'll start this calculation by saying that the reluctance of the magnetic circuit, which is represented as S, is equal to the length of the magnetic circuit divided by mu naught times the area over which the flux is applied. And so remember, here mu naught is the permeability of free space, and it represents, I guess, how easy or difficult it is to set up flux in the air, which again is considered to be free space, I suppose. Now, we are told that the air gap has a length of 2.54 millimeters, but remember we must use a unit of meters, so 2.54 times 10 to the negative 3 meters. For the length, we will divide that by mu naught, which is 4 pi times 10 to the negative negative 7 henries per meter, and we'll multiply that by the area, which has been given to us as 24 times 10 to the negative 3 meters squared. And so here, if you note the units, we have meters cancelling with meters, meters cancelling with meters, and so our unit is basically 1 over a Henry, and we'll find that that is consistent with the unit of reluctance, or amp turns per Weber is the unit given for that. So we have then, if we multiply this out on our calculator, we should be able to come up with 84,219.5, and our typical unit is amp turns per Weber for reluctance. Now, then our magneto-motive force is going to be equal to the flux produced multiplied by this reluctance, as typically, remember, magnetic circuit Ohm's law tells us that flux equals MMF divided by the reluctance of the circuit. So we should be able to say then that the required flux of 18 milliwebers is 18 times 10 to the negative 3 Webers. We multiply that by our reluctance, 84,219.5 amp turns per Weber, and then we have calculated an MMF of 1516, and the unit is amp turns, or it's simply AT.